Okay, templating. So I literally just stopped the video and started it up again, just because this particular subject, A, terrifies me a little bit trying to do the live coding for it. The syntax for templates are a little gonzo. They're a little bonkers. That's fine. We'll look at that, and it's a weird kind of quirky thing in C++. Most other languages have something like a template, but they don't have the syntax is not quite as clunky. I'm not a big fan of the syntax here. So let's walk through it. The idea is if I have these data structures, they're pretty useless if I can only use, so like our linked list from the slides only takes in a string. The linked list from our sample code only takes in an integer. If I want to store something other than an integer or a string, well, I got to make a brand new linked list class and have a all new type of data going into it. That's garbage, right? That's really hard to work with. So templating allows, and when we look at the standard template libraries, we're going to see templating again. The templating allows me to do things like, so for the STL, I have a sorting algorithm that takes in an array of data. What kind of data? It doesn't care what kind of data. The only thing needs you to guarantee is that the data that you're trying to sort can be compared for a greater than. So I need to be able to see if element 1 is less than element 2 or element 5. That's all it requires. If it matches that particular criteria, we're good. That's all it needs to make sure that I can pass in any kind of data into this sorting algorithm and it works. That's what we want, right? I want to be able to put in anything into a linked list and it works. That's the hope and the dream. So I want something very generic that can store any kind of data. I don't want to have to rewrite my code. And so what we will do is create this idea of a templated class, a class that takes in data of type T, and literally we use the value T or the letter T just to indicate like, yeah, this is something. What kind of thing is it? I don't know. It's something. We'll figure it out later. So my linked list takes in any data of type T, and then afterwards you figure out what the hell T is. Honest to God, you don't know what it is, and we'll figure it out on the fly. When you go to compile it, it will actually make new versions of the linked list classes. Make new versions of linked list. If I make a linked list with an integer and a linked list with a string, it will make a linked list that takes in strings. It'll make another class with linked lists that take in integers. It will make new versions of my linked list class. Behind the scenes, you don't see this at all, but when I go to compile, the compiler generates these things. The final object code in the final exe has multiple different linked list classes that take in different types of data, and that's completely hidden from you. So we say it's going to take in data type T, and then later on we will make the right class based off of what type of data we used. It's weird and it's wacky, and so we're going to use template T, and we're going to make a templated class, and then we will make functions that use that templated class. So it will be something like LL node is a templated class. It will take in data of type T, and then my linked list will have a function that takes in a LL node which is of type T, right? It has the function itself will take in special kinds of data. This will be a massive find and replace operation. That's all we're doing, but the syntax can be hard enough that it can be confusing. But I would love it if you guys made a hash table or any of one of these other parts of the assignment and made it use a template. That's really what ideally I'm looking for, or I would love to see. So the compiler needs to know what kind of class it is and a definitive kind of class. It can't deal with sort of a generic, I don't know, some kind of class approach. So it creates the right classes during compilation. You say, I need, this is a linked list. It will take in data of type T. And when I go to compile, it says, okay, what kind of classes were being stored in this linked list? Oh, it's a string. Okay, I will make a linked list that takes in strings. We can do this with our node link diagram as well, by the way. But you need to put everything, that's why I wanted to double check this one. You need to put in everything in your header file, and then the syntax gets a little wonky. So we'll look at this in a live example. So anything that was in the header file needs to go in the CPP file. I cannot have things that are only in the header file that are not in the CPP file, I don't believe. There's some extra workarounds. There's a fair number of hoops you have to jump through, but it gives you a lot of power if you do it. So normally I make my data structure for a particular kind of data, and then I template it afterwards, because the templating afterwards, it's hard to debug it later. If I make it work, the data structure work for integers or make it work for strings, later on I can make it work for any old kind of data. So that's the hope. So here's how a templated class works. I will say it's a templated class, template, and then I will say what type of template name I have. Normally I'm just going to use a T everywhere instead of node type and special names, because everyone that looks at the T goes, oh, that's a templated class. And then here's my classes. This is actually my little stubby saying, hey, by the way, there's a templated class named list that I'm going to need. Here's my node type. It needs to know about the class list. All right. So this is a templated class that takes in a node type, and the name of the class is node. So node takes in some kind of data, some kind of node type. It has a friend class of type list, which takes in some node type. Notice it has to have the same name between the two of these things. It's saying, I will have a friend class named list that takes in the same type of data that I have. If they don't match up, I don't know that they're taking the same kind of data. So here's my constructor for the node class. It takes in a constant of type node type. What kind of type is node type? I don't know. Some kind of data. Right? And I can pretend that I'm essentially going to pretend this thing node type is an actual class type. It's like, let me think of it, like an integer, like a string, like some kind of data that I'm storing. But I'm just saying it's this generic, I will figure it out later. But we're putting a generic name for the kind of data that's going in. The info coming in is of type node type. What's node type? I'll figure it out later. I will get oh yeah, I guess it might be have to be purely in the header file, which would suck. We may have to look into that a little bit more. So this thing is going to take in it's going to get data of type and it's going to return type node type. What type is that? Well, it's just going to be whatever my data is. Here's node type. Notice what I had before. It instead of saying data type string, it is now node type, node type, node type, node type, right? It's going to, and I'm also going to record my next element of type node type, right? That's the refrain. So it announces that it's going to be generic type, and it's going to be replaced later on. The compiler is going to replace it. So I'm putting in some generic something. The object type is, some kind of object type, and I'll figure it out later. I do a find and replace everywhere I had a char star in the original examples. I now have type node type. It's a list that takes in a char pointer. Well, now it's a list that takes in a node type. And instead of passing in a char pointer, it takes in a node type. And I need to know about for declaration, knowing about the list class. And the list class is also templated. So here is my templated class. I may need to migrate everything over to my header file, so we'll have to look into that. I always forget every single time, so we'll walk through this and debug it as we go. Here's my header file. It's going to take the first and the last. Hey, they're generic type node types. My list class takes in a node type, a node type, a node type, a node type. Right? Everywhere I had char star, I now put in this generic node type. And here is my I'm taking in here's my constructor for the list. it's just going to take, so I need to write this like template node type on top of every single function just for the compiler to know that that's what's happening. This is why I get annoyed with it. There's a lot of syntax to make sure you get right in order to make this thing work. And if you don't do it right, the error messages are a bit opaque. All right. So the basic idea is I'm going to just replace the word node type everywhere, or I'm going to use T everywhere. Um, and I want to be able to store anything. I don't care what kind of data it is. It's just data. I'm going to store some kind of payload in there. And so let's actually do a quick coding of this and see what we get. So I've duplicated my original demo, the linked list demo. Uh, and we have all this horrible print list code and stuff like that. Fine. I'm going to need to go through every single one of my classes. I may have to, this might take some time. I may pause the video and start up again. I'm going to go through each one of my classes and change what I'm doing. So the double linked list node, the linked list node, all this stuff, it's all going to be the same template type. And I need to make sure that I'm using the right, I'm going to use capital T. Okay. And I want to make sure my syntax is right. So that's wrong. PowerPoint presentation. Yeah, I always template and then type name and then T. Template, type name, T. Template, type name, T. Everywhere. And then I'm going to use T all these places. On top of my functions themselves, though, I need template, type name, T. All right. Every time it's I find it hard to remember. All right. So that should, so I'm going to take some kind of template type T. I also want to make sure it's a template class. So let's go back up to the template class. That's just above the word, the class definition. All right. So let's go back in here because I'm on top of a struct right now. But since I'm going to copy and paste it a bunch of times, that's fine. All right, let's copy this. Great. So what do I need here? I don't want that ID anymore. And this would be T. I'm just going to keep it as ID. It's not a very good name. Maybe I could change the name everywhere. So data. There you go. I'm going to have a bunch of errors from just the fact that it's not the data, but I should be able to do this. I want to look at my header file just to make sure that that's looking correct. I don't need anything here. This thing is going to take, I want to make sure that my constructor is looking right, so I'm going to just jump back here. My constructor, because my templated class, the list, does not take in a particular thing. Let's go back a couple more steps. This will take in a node type. I don't need the template node type at the top. This is actually up here. Okay. Every time. All right, so I can get rid of this most places, but I will need it everywhere for my CPP file. This will take in a type T, and we'll actually have to look at this. This will take in a type T. I need to get, this will be returning a type T. Get next, but this will be a get next of type T. This will be get the type, fine, linked list node of type T, linked list node of type T. So I can get the value, maybe I need a pointer to of type T. No, I can return the actual thing. That's fine. Okay, so I'm going to set data. I'm going to take in a T data. Get next, get data, get type, get data. That's going to be changing the names too, because I want to change it from ID to something else. All right, so this thing will be getting the next. It'll be taking of type T as well. Everywhere I'm The node length is going to stay the same. Set data is going to be turning this thing in. Okay, that should be fine. Great. I'm going to go to my linked list node and we'll walk through this one here. This thing is going to take, this is taking in a particular ID, so I'm going to take in T data, and I said every single one of these constructors, every single one of these things that takes in a template, I need to put this thing on top. A linked list node of type T, and this is data, okay? And this data, and set all right, I'm calling set data, fine. Data is of type T everywhere, okay. I might have a problem with this. I'm going to look into that a little bit. This, I need to make sure that it is my, I don't know if my destructor needs that. Well, we'll leave it in there. Let's find out. Get data. It's going to be of type T, so I have to put that in there. All right. And there's the T. And there's the T. And there's, so I'm going to return this to, it's going to return a type. It doesn't need anything special. Oh, I might need this part here, but I'm not sure. Well, we're going to put it in there anyways. Let's put it in there anyways. Let's find out. All right, this is going to return a linked list node. The node itself is going to be of type T, so I definitely need that here. It's just so many hoops to jump through on this thing. I might just stop my video after I do one of these and then do the cooking show approach to doing this. I'll just give you the actual end result afterwards and go over some of this stuff. But I want to make sure that I show you it in action and my thought process on how I'm doing this. I'm just going to go through each one of these parts, and I'm going to insert something afterwards. So I need that's a templated class as well. It is everywhere. I have to put these templated classes things in because all the data everywhere is going to change. I'm going to set the particular ID and I'm going to set the data, and that is a T data, and I'm going to get rid of this old value, wouldn't add negatives, and so my set data is going to be this. It's going to be data is equal to data. Notice what I have there, just in case you're wondering. Just a reminder, my member variable is named data. My input parameter, or the input variable, is named data. How do I distinguish between the member variable and this parameter? They are different values. Well, that's where the this comes in. This says use the member variable data and set it to whatever this parameter is. Because this, the word data, if I just use the word data, it naturally assumes it's the input variable going into this function, not the member variable. There's the member variable, here's the input variable. They are different things, and that's what leads to all sorts of, that's why the this is somewhat critically important. All right, I'm going to put in a T here. I'm going to get data. I don't know why that hasn't yelled at me yet for the getting data yet. Okay. It is just ugly syntax. I fully admit that one. All right, get the length. Okay, that's fine. All right. It should yell at me for all sorts of other stuff because all of the other node link diagram stuff is going to, it should blow up because the doubly linked list, for example, has to also be changed. Doubly linked list, a linked list, doubly linked list node. All of these things are all templated classes now, or need to be templated classes now. And so I will need to do things like this, put in a template T, and it will be public linked list node and of type, my linked list node will be of type T in here. And everywhere I had what I had before. So this will be data. I have a previous. I might need double linked list node T. T. My data itself is of just type T. Set previous, insert afterwards. Okay, and get previous. All of those are fine. All right. And so that's one double linked list node. I'm going to have to go through each one of these things and change them. Okay, so this is going to be my data, and it's going to be type T data. I'm going to put on top of each one of these functions, I have to put in this templated thing to say, by the way, it's going to be templated data. And so there's so much little bookkeeping when it comes to how I move this stuff around, or what I'm going to be doing here. Okay, so this is going to be a node of type T. That's the previous that I'm dealing with. It's going to be type T here. All right. Set previous, insert afterwards. We'll look at where the errors pop up actually. But they will be everywhere. It's really quite frustrating. All right, this is going to take in this. Get the previous. It will always be of type T each time, and I have to put it all these places because if I don't do that, what's going to end up happening is my data is not going to work the way it's not going to. If I don't put this T everywhere, it's not going to know what kind of element I'm going to be dealing with. It knows the previous is going to be of type T. That has sort of been established, and it's a DLL of type T. But if I don't have this matching everywhere, it's not going to know what to do. So I'm also going to have to change my my stacks. I'm going to have to change all of these things. So what I'm going to do right now, I'm going to put a quick pause on this. I'm going to modify all the rest of the code. I'll come back and then we'll look at. I'll probably leave a couple errors in there just to show you guys how I'm walking through all of this stuff, and then we'll go from there. But it is a rather big overhaul, but it's a lot of copy and paste and a lot of just plugging away versus a lot of thinking. It's just repeatedly just putting in the word template type name T. All right, so back in a second.